Hello, my name is Ahmed El-Rayes and our startup is SweepTEQ. SweepTEQ is a robotics company which actually provides robotic solutions for airports. So the problem we are solving is basically pieces of debris in the airfield is responsible for damaging aircraft engines. When an aircraft is in the airfield, it ingests the debris from the ground, breaking the engine blades, translating into millions of dollars in maintenance cost every month. For this reason, we are providing autonomous robots which will go down on the airfield with computer vision and autonomous motion planning. It will go and collect any debris it finds in the airfield. This way, we're saving maintenance costs, and also we're saving the human power which is currently deployed to collect debris manually and improving the overall airfield safety. Some of the main functionalities of the product is first, it does autonomous motion planning. So we have different modes depending on how much time we have between the flights. So we only scan when the aircraft stand is empty. So when our aircraft just leaves the stand, we have between 3 to 5 minutes before the next aircraft comes. If we have enough time, we do a motion planning with detailed patterns, so we can cover each and every meter in the aircraft stand. If we don't, we just cover the areas which are expected to be under the aircraft engines and the tires to save time. Basically, it starts with motion planning. Computer vision will then try to track any debris it finds. If it finds something, it goes and collects it. If the debris is larger than the size of the robot's capacity, it just reports it to the operators, because if there is a large object, no one is allowed to pick it up because it could be a part of an aircraft. So these are regulations that we just follow at the airports. So once we collect the debris, it comes back, it puts it in a debris compartment on board on the robot, and then once it's done, the operator can actually remove the compartment and then get rid of the debris in the debris bin at each aircraft stand. Also, this robot, after it's done from scanning, it provides debris analytics regarding the size, the location, and the material of the debris it found to help airports in the future to prevent the sources of debris. For the hardware part, we have been using our objective, our criteria was to actually design a custom-made robotic platform that is capable of collecting any debris in a wide band of sizes. So it could be a little piece of coin on the ground, or it could be like a big plastic bottle. If the object that we have to pick up, like I said, is larger than the capacity of the robots, we are not allowed to pick it up. We have to report it because it could be a piece of a plane. Investigations need to happen. The other pieces where the other criteria is this robot motor should be fast enough to navigate in an aircraft stand, which is almost around 100 by 100 meters. Minimum, it would be 60 by 60 meters, so it need to be fast enough to cover these areas. For the processing of the robot, we're using NVIDIA Tegra board for its decent speed and processing speed to carry out the computer vision and at the same time control the robot's mechanics. Moreover, we're using a dual camera system on the robot, which can help us actually, so the differences in the images between the two cameras can tell us how far are the objects, the sizes of the objects, and with further machine learning, we can tell actually the materials of the object at which it's made of. The way our software works is basically there are two parts. First of all is the motion planning, and the second is object detection. So for motion planning, we use three things. Now, this robot should not get out of the aircraft boundaries in the stand area, which is indicated by a white line the airport actually draws around the aircraft stand. So this is one thing the robot needs to actually look for with its cameras so that it doesn't cross that boundary. The other thing, we use GPS motion planning, so we get feedback from satellites. The third thing is basically we upload a blueprint of the airfield map. So we sync the three together and make sure that our robot doesn't actually exit the aircraft stand area. For object detection, right now we're actually using edge detection in computer vision, and we kind of think it's the most convenient way for this case, because the airfield ground colors may change to darker spots. Some water is spilled on somewhere at the airfield, so it looks darker than other areas, so we cannot use actually color detection, we use edge detection. What makes our product unique is actually a question we need to look for what our competitors actually do. So when you look at our competitors, their products are basically a bunch of radars and AI cameras spread over runways to detect objects on the runway. Our competitors only focus on detecting debris on airports' runways, and they only detect, they do not collect, even though they do the detection autonomously. We are the first to provide an autonomous solution that does both detecting and collection for the other areas of the airport, of the airfield, like the hangars area, aircraft stands, and the passenger boarding bridge path. So that bridge actually stretches out with the help of some wheels. We actually scan the path of these wheels, and we are the first one to provide autonomous solution that does everything, from detection to collecting and providing analytics. One of the biggest challenges actually in the mechanical system should be really able to collect really tiny metal pieces. For example, we're looking at, you saw that the cap of a can, when you open the can, that little metal piece, that thing is annoying. We should be able to collect it. We are very concerned about metallic pieces because they are the ones also highly responsible for damaging aircraft engines. Even if it's a pound on the ground, these tiny objects, how we can actually sweep them into our robot, they're kind of challenging and tricky. Other challenges we're looking at, how can we differentiate between oil spills on the airfield and water spills on the airfield? So is this rain or is this oil leaks from the aircraft? So this is one challenge we are looking at right now. Other challenges is what happens if we have fog conditions, what happens if it's heavily raining or there's some visual impairment problem so we cannot see the airfield. We're looking at thermal imaging cameras, but these are one of the challenges we're actually solving in terms of the technology in our product. We are planning on adding fixed cameras, which actually save the scanning time. So instead of scanning with our robot and it has to go and cover each and every spot on the airfield stand, we just fix a camera at something called a gantry. So it's like a metallic stand that is in front of each aircraft stand. We fix the camera over there and it keeps on scanning the aircraft stand 24 hours. So we have continuous scanning, and just once it detects something, our robot can come in and collect it and come out. This is a feature we're working on, but we won't see how good will it be, because this camera will be unable to close down. So our robot is expected to be better at detecting smaller objects, but the camera will be good at providing a continuous scan all the time. So what attracted me to Startupbootcamp IoT program is actually the valuable partnerships they have. For example, when you're a startup that's dealing in the aviation industry and you see Startupbootcamp having a partner like Rolls-Royce, who's also similar in their business, they also deal with the aviation industry, it's good to learn from their experience too. The other thing is, I like how Startupbootcamp IoT have big experience in hardware development with startups. For example, when you look at their partners like RPD and these things, you believe that this is the right place to support a hardware startup like ours.